Welcome to another awesome edition of Comet Algebra. This video is for Algebra 1, Chapter 6, Section 3, Slope-Intercept Form of a Line. Now we've already learned when we studied the standard form that there are infinitely many ways to write the equation of one line. And this particular form, the slope-intercept form, is very useful. So if you recall, we already know that this ax plus by equals c is the standard form where a, b, and c are not fractions or decimals, and we learned that this number is positive. If we take this, or really any other form that we have this equation in, and the key is that we solve it for y. So this is one of the reasons why we studied literal equations, so that we could use that skill. So no matter where the y is buried in this equation, it's right here, we solve for that. And when you solve for that y, we write it in a form such that we have y equals, and then we have the x term first, and then the constant. Now mathematicians have chosen a small letter b for this constant, and it's a different constant than what is in the standard form, so we don't want to use the same letter anyway. But typically we write the x term first, and then we put the number. And this coefficient here in front of the x is very, very important. This m is the slope of the line, and this number, it could be a fraction, could be whatever this number is where that line crosses the y-axis, and we call that the y-intercept. So we're going to have to be able to move from, if we have the slope-intercept form, we rearrange it, and we can write the standard form, or vice versa. Given the standard form, we rearrange it to the slope-intercept form. If they give us a slope and a y-intercept, we put those numbers in the right place here, and we can write the equation of the line. Or if we have the equation line, we can pull out the slope and y-intercept. We're going to be looking at this from all different angles. Example 1 gives us the equation of a line, obviously in standard form, and it would like us to change it into slope-intercept form. And so what we just learned above is that we need to solve for y. After we do solve for y, we are going to state what the slope and y-intercept are in this case. So the first thing we do when we're solving for y, again I'm just going to put an arrow, that's the letter we're solving for. Let's subtract a 3x from both sides. So now I would have 2y, and let's get in the habit of putting the x term first, because that's going to get us closer to slope-intercept form. Now all I have left here to get rid of is this 2, so if we divide everything by 2, and I mean everything. Please don't skip any of these terms. There's 3 terms in this equation, and they all have to be divided by divided by 2 to get y alone. So now I have y equals negative 3/2 x plus 3. So this is in slope-intercept form. Next thing we're asked is to state what the slope is and to state the y-intercept. I'm going to always call the slope m, so let's get accustomed to that. In this case, m is negative 3/2, and the b, the y-intercept, is a positive 3. And all we did is just pull them out here, because there they are right in the equation. The slope is the x coefficient, and the y-intercept is the constant. The next thing we're asked here in part B is to work with that equation and state that same line 3 different ways. Well, the standard form is easy because that's what we were given at the beginning of this problem. So I'm just going to rewrite the standard form, just kind of so we can compare it. And then we solved that for y and put the x term before the constant to get this into slope-intercept form. And then if we were to write the function form of this, sometimes we called this the function notation form, same thing. We simply take out the y and put in the f of x. Because remember, y and f of x are interchangeable. All linear equations can be written in function notation form except one kind of line. We cannot write vertical lines, the equation of vertical lines, in function notation because there is no y in the equation of a vertical line. Remember, a vertical line would look something like, I don't know, x equals 2. And then right here at 2, it would just be an up and down, a vertical line. And that, like I said, there is no y, so we cannot write that with function notation. But that's the only exception. Next thing we're going to do is graph the line using the slope-intercept form. You do not have to make a t-chart. You just need two pieces of information. You need to know that the slope is 1/2, and I'm just pulling this right out of here. It's the x coefficient. And the b, or the y-intercept, is this constant 4. This is all we need. So we start here. This y-intercept is our starting point. So I go here to the graph. The y-intercept, of course, this is the x. Here's the y. So we go up 4, 2, 3, 4, and we put a dot. I'm going to use a little x here as our starting point. Then we use this slope and we count it out by counting the little squares. Now this is a positive slope, so remember we got to go uphill from left to right. So starting here at the 4, we go up 1 and over 2 and put an x or a dot. 1/2 means up 1 and over 2 and put a dot. Up 1 and over 2. And you can count the pattern backwards a little bit if that helps you to make a straight line. Down 1 over 2 this way. We should be able to count that pattern both forward and backward. Now I'm going to attempt to make a straight line with this pen. You know, it's a challenge, trying. Okay, not too bad. I'll take it. So just reviewing how you graph from this. You start at the y-intercept and count out the slope. And of course the domain is all reals, so you do connect your dots. All right, this example, we are to write this standard form as a linear function. And what your book means by that is a y equals function. So we'll do that and then we'll graph it. So once again, to start solving for y, we subtract the x term from both sides. So then I have 3y equals negative 2x minus 3. And then dividing everything, and remember it's everything, by that y coefficient. So then I have y equals negative 2/3 x minus 1. And remember they asked us to write it as a linear function, meaning they wanted to see this in function notation. So we're going to take out the y and put in the f of x. And then we graph it the same. I'm just going to remind you here, the slope, the m, is negative 2/3. The b, or the y-intercept, is negative 1. So let's go to the graph. Let's go down 1 to the y-intercept. I'm using x's because you can't make little circles with this software. So go down to negative 1. Now this is a negative slope, so we know it's going to be going downhill from left to right. So from our starting point, we go down 2 and over 3 and put a dot, down 2 and over 3 and put a dot. And once again, you should be able to count this pattern backwards, 2 and over 3, to help make a straight line. All right, here we go again. I'm going to try another straight line because the domain is all reals, so we do need to connect the dots. All right, not horrible, but not great. So we did graph the function. Let's look at a different type of example here. We are given y equals 3 and asked to write that in slope-intercept form. So let me just remind you what slope-intercept form looks like. Y equals mx plus b. And we don't have an x term here. So what that means is that the slope is 0 because 0 times x is 0. So the best I could do writing this in slope-intercept form would be to write y equals 0x plus 3. Now, we usually never do that. We usually just write y equals 3. But I wanted you to see what that would look like so that you can easily see that this slope is 0. When you're given this, hopefully what you can pull from that is that the slope is 0 and the y-intercept is 3. So once again, let's start at the 3. So we go up 3. And a slope of 0 is like walking on the prairie. It's a flat line. And so the line graphed would be just right there on that y equals 3. And wow, I think that's the straightest line I've ever drawn. Practice is helping. So now just to talk a little bit, why if we were not asked in this problem, but if we were asked to graph x equals 2, for instance, you can't write this in slope-intercept form because we don't have a y. And if you were to think of this as a y-intercept, there isn't one. This 2 isn't a y-intercept. So this is really different. This x equals 2, it doesn't have a slope and it doesn't have a y-intercept. It really has nothing to do with the slope-intercept form. To graph x equals 2, you just come over here to 2 and it would be a vertical line, which, okay, yeah, that's more than normal for me. I can't usually draw a straight line. But vertical lines sort of break all the rules. They don't have a slope. The slope doesn't exist. There is no y-intercept, and we certainly can't write it in a slope-intercept form. But this y equals 3, your book calls that a constant function because the 3 is the constant. Now let's just briefly discuss when we use the slope-intercept form in doing word problems. The slope is something you're going to have to identify as you read the problem. And with practice, I hope this gets a little better. We want to identify the slope, which is really, it's called the rate of change. It's how much something is increasing or decreasing. So I know we could use the word increase here. Some problems, the change will be a decrease. And the other thing we need to identify in our reading of the word problems is what is the y-intercept? And this is what is referred to as the start or the starting value. So please write this down. Instead of mx plus b, for the m, I'm going to have you write in the word change. And for the b, the y-intercept, we're going to refer to that as the start. And so that's going to be part of our discussion in class. I'll ask and we'll discuss which of these numbers in the word problem is the start and which is the change. So think of those two things as we're reading this. An online photo company makes albums when you upload your pictures. So this person decided to become a member of this site, and she paid a membership fee of $25. So right now I want you to start thinking, is that the slope? Is that how much it's changing each time? Or is that the start and the y-intercept? A photo album that she orders will cost her $1.25 per page, and she does get free shipping with her membership. So now you're looking at this from the point of view, which one of these numbers is the slope or the change, and which one of these numbers is the y-intercept, or what we refer to as the start. And hopefully you're seeing that this $25 is kind of the start of the cost of what she's going to be paying. So this $25 is the B. It is the start. And this is what's going to change depending on how many pages she orders. This is the slope. Every page is going to cost her $1.25. So this is the amount that it's going to increase. And the number of pages, that's the X. That's what changes. with depending on how big or how small of a photo album she orders. And so first we're going to write a linear function rule for what this is going to cost her, and then we're going to graph it, and then we need to use our function rule to determine how much will it cost Sarah if she's going to make a 23-page photo album. So again, the $25 is the start, so I'm going to just go with the y equals. The slope is $1.25. The x is how many pages, and this $25 is what she paid for her membership. So now we need to write this as a linear function rule, so let's put it in function notation. F of x equals 1.25x plus 25. Now let's graph that over here. So on the graph, pages is the independent variable, so it's down here on the x-axis. Cost is the dependent, so it's on the y. I chose to count by fives on this graph. The start of our graph, the y-intercept, is $25. So let's come up here and put the starting point on 25. Now, because I'm counting by fives, this 1.25, this slope, yes, it is 1.25, but that's going to be difficult for me to count. So I'm just going to write an equivalent fraction here. We know that 1.25 is the same as 125 over 100, and that reduces down to 5/4. So this might be a little easier for me to count going up 5 and over 4. So up 5 is a whole square, and over 4 is not quite a whole square. So right there, up 5 and over 4, up 5 and over 4, up 5 and over 4. So, wow, that's going to be hard to draw a straight line. Okay, that's not too bad. And then the last thing they want us to do in this problem is determine how much it would cost Sarah to pay for her membership and a 23-page photo album. So there's a couple ways to proceed here. If I felt like I had an accurate enough graph, I could go over here to 23 pages and then look up and see, well, I can tell it's going to be just more than $50, but not $55. But I'm not really that happy with the being a little off there, of not having all the accuracy I would like. So the other option, algebraically, we can put the 23 in for x and find this more precisely. So whether you use the graph or the algebra, putting the 23 in for the x, let's see what we come up with for the cost. So if I did the math right, I ended up with $53.75 using the algebra. And using the graph, I came up with, more than $50, but less than 55. So a little more accurate with the algebra. All right, now I think you have the knowledge you need to do section 6.3, so have fun.